Welcome. We're going to look at a rate of work problem today, and the problem statement reads as follows. Krystal can wax a floor in 16 minutes. When her friend Perry and her work together, the same job only takes them 5.76 minutes. We want to determine the number of minutes it's going to take Perry to wax the floor should he work all by himself. One of the first things that we notice in a problem like this is that when Krystal worked by herself and it took her 16 minutes, but then when the two of them worked together, it took them less than half the time that it took Krystal. Half of the time that it would have taken Krystal would have been 8 minutes, but in fact, it's taking less than 8 minutes for the two of them to work together, and so we can infer from that Perry is working at a faster rate than Krystal. So let me write that over here. Perry works at a faster rate than Krystal. To try and achieve a solution to this problem, we will use a graphical approach, and I'm going to just draw a work versus a time plot. Let me draw the work on the ordinate axis, which is the vertical one, and the time in minutes on the abscissa, which is this horizontal coordinate axis. I can draw Krystal's graph right away by a straight line. Let's suppose that's Krystal's graph right there. And let's suppose also that this right here is the 16 minutes that it took Krystal to do the job of waxing the floor, which I will just denote as W. I know that the slope on this curve, the rise over the run, is just W is to 16. I also know, as we just mentioned, and I'll draw this in a different color, that when Perry works all by himself, he's going at a faster rate. As we said up here, Perry works at a faster rate than Krystal, and so I expect his curve to be at a higher rate, such that this is still W to do the same job, but we don't know what this value is, and that's what we're trying to determine. So let's see how we can determine this T sub P, the time it takes Perry to do the job. Let me go ahead and label this black curve P and the blue curve K. So that's the Krystal curve, and the black curve is the Perry curve. When they worked together, it only took them 5.76 minutes to do the job, which we will write out over here. This amount right here, the height of this, is the work that Krystal did when they were working together, and this height here is the work that Perry did. So Perry did at least the rate at which Perry was working was faster, and so in the same amount of time, which is 5.76 minutes, Perry did a lot more work than did Krystal. Now, interestingly, we have two triangles sitting over here that are similar. One is this one, and the other would be, of course, this bigger one. I can, by similar triangles, determine some information. So let me write that over here. bisimilar triangles I have that W sub k, which is this amount, is to 5.76, which is this amount. That's this triangle right here. That is equal to the W, which is this amount, is to the base, which is this amount. And to solve this, I would multiply both sides of this equation here by 5.76, and if I do that, I find that 5.76 divided by the 16 times the W, which works out, if you use your calculator, you can show that the work done by Krystal is only 36%. And so from here, we can find out that the work that it took Perry has to be the difference. If it took Krystal 36%, then Perry was obviously doing the balance of that, which is 64%. Having done that, we can now look at two more triangles. So I'm going to look at this triangle versus this triangle. Alright, so let's look at those two triangles. So in the first case, we have W sub P, which is this amount, is to the base of 5.76, which is this amount, and that has to equal this amount, which is W, is to the base, which is T sub P, and we don't know what T sub P is. That's what we're trying to determine. But we do know one other thing here. We know that W sub P is equal to 0.64 W. We know that from this relationship right here. And so if I stick in 0.64 W is to 5.76 as W is to T sub P, I can eliminate the W's from the left and the right just by dividing by W. And then I can solve for T sub P, which is what I need to know, is equal to 5.76 divided by 0.64. That means that if you do that on your calculator, you'll find that 5.76 divided by 0.64 is 9 minutes. So this is the amount of time it takes Perry to wax the floor when working by himself. Well, I hope that made sense to you. We used a graphical approach, and we also used the method of similar triangles, where we put things in proportions, and we were able to then get relations from those similar triangles. Two of those triangles are these purple colored triangles, this one and the bigger one, and the other two are these triangles, this smaller green one and this bigger green one. And from all of that, we were able to determine this T sub p, which was the unknown, which works out to being 9 minutes, should Perry do the job all by himself. Thanks again for watching, and I hope to see you again in a future video.